Good day for everyone. Today we will review how to calibrate the primary energy sources using a starter data kit with OSeMOSYS and also Clixen. The first step is to open our hands-on with all the instructions, so please go and find the file, try to open it, and here you will find all the instructions. Please try to read carefully everything before starting to check this video because it will make easier to understand what we are talking about. So the idea essentially is to collect the input data of primary energy sources in terms of both fossil fuels and renewable energy sources, and also to use those values to calibrate those potentials in an osmosis model. The first part is essentially to calibrate the fossil fuel reserves, so it means for crude oil, natural gas, coal, and uranium. Here you need to do some research, especially using some national sources, like for example the Energy Ministry or the Energy Institute that you have, or some official documents. However, in order to provide you with a hint of what kind of values to look for, here you can see the statistical review of world energy. So let's take a look at this for having an idea of those values. For example, let's open it. It is going to show you an Excel file with too much data. I really recommend this document as a good source for finding good values. So in this case, for example, let's say you can find values for oil, for crude oil, you can find values for natural gas and also for coal. However, in terms of uranium, you will need to use essentially more national sources for finding what are the reserves in your country. Let's use natural gas just as an example. So you can click here. You will find the reserve in different years. In this case, we will use the most outdated one. So at the end of 2020, it means that we can use this as a value in 2021. We have the value in trillion cubic meters and also trillion cubic feet. Let's use an example. For instance, let's go with Algeria. So in this case, we will use the value in trillion cubic feet. This is around 80.5. We can go to our calibration template, which is pretty important. This is like the second document that you need. First one is, as I mentioned before, the hands-on in PDF, and the second one is the template that we will use for this calibration. In the first step of this file, you have the fossil fuel reserves. Here you will find three different tables. It is going to depend on what is the value that you are using for the different reserves. So for example, let's assume that you have the value in 2021. So you need to use the first table. Of if you have the value in 2022, you can use the second one. Or maybe you have a very good outdated value, so reserve in 2023 would be the one. So coming back to our example, we have the value in 2021 that it was 80.5. However, it was in trillion cubic feet. We can use the second tab here that is about conversions. We have some values. Notice that here the conversion factor is in billion cubic feet. So it means that we need to convert from trillion to billion. For example, let's do this. This is just a template, very flexible, so you can modify it or adjust it according to your needs. So for example, let's say here that we're using trillion cubic feet, and then we have billion cubic feet, and here we will have petajoules. So how does it work? Essentially, as we know from our source, trillion cubic feet would be 80.5. After that, to find the billion, we just need to take this value and then multiply this times 1000. In that way, we will get the value in billion cubic feet. And finally, to convert to petajoules, we need to take this value and multiply this times the conversion factor, that it would be 1.01. And then voila, you have the value in petajoules. We just need to copy this, go to the tab. Let's look for the natural gas technology, that it would be the mean gas, and then you can copy the value just as a value like this. Okay, as you can see here, the let's say yellow cells are the ones to be completed, the rest of cells are automatically formulated, so you don't need to modify those. So please just try to be focused on what are the cells with a yellow color for this template. Okay, now let's consider that in the starter data kits our starting year is 2015. So it means that we need to consider what were the productions in the past years, because in that way we can consider the reserves like brought to 2015. So we need to also to check what are the production in 2000 from 2015 to 2020. So in that case we can also try to use our resource here. So for example, here we have the production in both billion of cubic feet, and also we have exajoules. So just let me check it. So here we have this value. Here we will use this value because it's much easier to use it. So in this case we will look for Algeria once again. Let's remember this is just an example. We can take the values, so we need to look for from 2015. You can take this, copy this until 2020. Let's copy this. Let's go to our template, copy the values. Then we have the values already. Let's remember that they are in exajoules, so to convert this from exajoules to petajoules, we can multiply once again by 1000. So we just need to take the values times 1000. Then we have the values for all years. Then we can copy those and paste it here just as values like this. Okay, and then automatically you will find the value of reserves in 2021 for 2000, the reserve for the modeling period starting in 2015. Okay, so this is the kind of exercise that you need to do for natural gas, for crude oil, for coal, and for uranium. Okay, now let's go to the second part, that would be to calibrate this using the starter data kit. So according to the instructions, you should have one file like this, just like starting with version 2. So let's remember that always that you are doing changes in your file, it's very important to create a new copy. In that way, if in case that the next run of your model gets invisible, you can come back, review what are the new values that you inserted, and then just to try to check where the mistake was and try to run it again, so you are not going to lose everything that you did before. Okay, so in this case we are going to do this just like for showing you how it would be. So just make a copy, and then it will be version 3 for this exercise, and then let's go and open it. It is going to take a little bit here in my computer, so just let's wait for this. As I was mentioning before, don't forget that, for example, here you can use table number 1 because you have the values in 2021, but if you have crude oil with more outdated values, you can use the second table. It doesn't matter, you can use the table that you need depending on what is the date that you have reported for your reserves. So here we just need to enable the modification of the file. I will remove this filter for technologies. Then the parameter that we need to do, that is always here, this is something as I was mentioning before. You need to complete a kind of this table. Then you have the conversion factors as I was mentioning before, and then what is the process? You need to modify the total technology model period activity upper limit. That is the parameter that we use in OSeMOSYS to define what is the maximum limit of energy supply that you can get from a source, so that in this case, in the real world, it would represent the reserves. Okay, so in that case, again, for our example, let's remember that for the case of natural gas, all the natural gas reservoirs, where is like the primary source for natural gas, is the technology of mean NGS, or mining natural gas, right? So first step, let's filter for this technology, mean NGS. We will get that, and after that we will look for the second parameter, the parameter of total technology. It is like very long, so try to be careful with when you are looking for, but it's like this one, total technology model period activity upper limit. Okay, so it would be the upper limit. In this case, it is loading, and then we are here. So notice that here we are modifying this value, and in this case it would just be like, let's go to your table, take your value, this is the outdated one, then go here, and don't forget, always try to paste it as value, not as a formula, because otherwise you will get an error. So please just copy this as a value, and like that it will be all. Then once again, let's remember that you need to repeat the process for crude oil, for uranium, and for coal, depending on what is the resources that you have in your country. In case that you know that, for example, your country doesn't have any reserves of coal, it means that the value here would be 0, because you don't have any reserves. Okay, so that would be the first part. Then if we come back to the guideline here, the second part is about the renewable energy potentials. Okay, so for the case of renewables, we have like kind of unlimited resources. So it means that the potential would be given by what is the maximum level of energy that we can supply annually. So in that case, we need to do it, or better, we can do it in two ways. We can do it in terms of capacity, that it would be in gigawatts, or also in terms of energy production in petajoules. So it is going to depend what kind of unit you have the values. So we will try to do this in both ways. We will try to do it in terms of a capacity unit or a production unit. Okay, so here is just once again one example on how the gathering of the data could look like. So in this case, you can see that here we have the values for solar, hydro, wind, biomass, geothermal, and everything is in petajoules. Okay, something that is important to mention that is considering here is like, for example, in case that you have potentials for both onshore wind and also offshore wind, you will need to do it it's better to do it separately, one for power wind 001 for the case of onshore wind, and power wind 002 for offshore wind. Okay, so now let's go with the second part of this. This essentially is how to find those values. Once again, it's very important that you try to go to your national institutes or other official studies that you can have, and then try to look for what are the values that you can use. Okay, however, once again, at the end of this hands-on, you can find different techniques for trying to estimate what are the values of these potentials. Okay, so you have one example on how to do it for solar PV, and also you have other values for offshore wind, for onshore wind, for geothermal, for hydro. They are just like suggestions or where to look for, where to search. However, many times you are not going to find all the information, because this is just for key countries, so it's like those sources are not like the best ones to find information. So please try to do a good research on where to find the values for your specific country. Okay, now here once again, just for having an insight of what is the process, we can try to do it once again, just like in the sense of having an example. So here let's try to do it for offshore wind potential. So in this case, for example, it's going to be in gigawatts. This is a great source with like a very organized information. So once again, we can go to the link. It is going to open this report elaborated by World Bank Group. And then we can see here that we have the technical potential. Remember that in terms of energy potential, you have the theoretical potential, the technical potential, and the economic potential. In terms of osmosis, it's always better to work with the economical potential. However, many times or most of the time it is difficult to find that. So technical potential would be like the second option for using it, and always try to avoid the theoretical potential because it is like neglecting different constraints and considerations in the calculation. So it's like very optimistic, which at the end of the day could cause like a very overestimation of the use of different renewable energy sources. Okay, so now here let's go try to give a preview. Let's check if we can get a view of this before moving forward. So okay, it's loading. So here once again we have the data in Excel format. We have this classified for the different regions. Let's try to use other country here. We have again Algeria, so just try to keep it as our example here. So we have Algeria. In this case, use the total offshore wind potential. So in this case would be the sum between the fixed and the floating technologies. So in this case, just let's take a look. Okay, here notice that the sum is equal to around 19.17. Always try to round down in order to avoid overestimation. So let's go with 19.17 gigawatts. So what is the process? If we want to include this value in our calibration, we need to come back to our Excel with the input data. We are going to filter what is the technology that we need. As I mentioned before, for offshore wind, it would be Power Wind 002 in this case. So let's go with that one. Let's try to check it. So it's going to be selected, and now regarding the parameter for the case of this potential, it would be the total annual mass capacity. Let's take this into account. It is the maximum capacity, maximum installed capacity that we can have of a technology, so it is useful for setting this limit. So in this case we can do that. Notice that here the value is set in 0, so it's not correct. So in this case we just need to put the value, and it was in this case is 19.17. so here we just need to copy the value, extend it, and then we can replicate it, and everything would be done. Okay, so that is a process. In the case of capacity, we have the value in gigawatts. Now let's imagine that you have the value in petajoules. So in that case, let's take another example here. Like for example, let's go with another source here. Let's check it. For example, the higher potential for some countries. Probably we are not going to find Algeria here. It's just for having an idea. So let's suppose that we will use a value assuming that is for the country that we are working on. So, okay, one approach that we could use maybe later is that, as you can see here, we have the potential in terawatt hour per year, yeah, right? So that is one important thing. So here we have the technical and the economic potential. In this case, we will use the second one. We will use the kind, this will be the full one, that it represents the total one. So here is you, for example, Algeria, if I'm not wrong, it would be located in the northern Africa. So it means that we can try to use it as a proportion. We can use a proportion here for this value and try to share what are the countries in that region and try to like make a proportion to find an approximate value. It could be a way for doing that, but it's not the best way, but it could be just in case that you cannot find other source for the value. I just want to check something, is just to verify that we are considering all the countries in the specific region, but I think that, okay, no, it is not here. But okay, let's assume that is Northern Africa for Algeria. I just want to not saying something wrong. You can see here that Algeria is part of Africa effectively. So yeah. So let's assume, for example, that for the Northern Africa, we have 266 terawatt hour as potential, right, in terms of hydro. However, let's say that just 5%, because we can try to find the proportion just like using, for example, GDP growth or land availability, etc., etc. We can try to find a proportion, or maybe energy consumption. I would say that maybe energy consumption would be a better approach. We can check what is the proportion here in this region. So let's assume that here 5% is the proportion for Algeria from this potential. So we can go here once again to our template. Let's say that is the total potential. Here is 266, and now for Algeria, that is our example, we will use just 5%, so it would be times 0.05, and in general it would be 13.3 as the value. Now let's remember that this is in terawatts hour, right? So you can see here also that the conversion from terawatt hour to petajoules is 3.5. So we just need to go here, try to take this value and multiply this times 3 times 3.6, and this would be our potential. For this case, we are talking about energy. This is in petajoules, as I was mentioning before. And then it is essentially the value that we are going to use in this value, right? So for example, you want to complete this, it's just like this value, we can use it here. It would be for hydro. We can copy it here. Also, we can add something here. So here, for example, we can use offshore wind, right? In this case, as we are using different values, we are not going to use this. So it would be offshore wind, and then we need to use onshore wind as well. So here is power wind 002, and then as we were calculating before, it would be in gigawatts, in gigawatts, and the value that we calculated before, it was I lost that, and I remember we wrote it directly, it was 19.17, right? And then for the case of hydro, as we were mentioning, is 47.88, right? So now, once we have all the values, it's just an example for hydro. So let's remember that we need to go to the template, go to the model. In this case, we will use the technology that we need, and in this case is mean hydro. This is our technology for hydro potential, and it is in petajoules once again. And considering that we are using energy, the parameter is different. It is not total annual mass capacity anymore, but in that case would be total technology annual activity upper limit. Notice that it's different from the previous one regarding reserves, because the previous one is about model period, but now we are talking about annual activity. So we need to select it, it would be done, and once again we have this value. Notice that here the model is not calibrated, so that is the reason why you have 9999, but now we know the value that is 47.88, so that would be the value, and now we just need to copy the value and paste it in the rest of the GRs, and that would be everything for the case of this example. Once again, you need to repeat this process for solar PV, for biomass, for geothermal, for onshore wind, for every renewable energy that you consider that can have a potential in your country. You need to repeat the process, okay? Once again, trying to check the different techniques for doing this, and after that you will need to finish by saving. So once you have made all the changes that you need, you just need to go save the model, and then you will need to create an input file and try to run it for checking that everything is working properly and the calibration was performed correctly. Okay, so once again, save it, run it, and check that everything is working properly. That would be all for this practice. Thank you so much.